Here we are going to start to discuss about integration. In integration, the basic thing you should know, when we integrate x to the power of n, okay, n is a constant, we don't know what is our n, okay, n should be, the condition n should be greater than 0, okay, n should be greater than 0, not equal to 0. If n is greater than 0, we can use the following method to integrate the particular values. Okay, in this case, when we integrate x to the power of n, it should be x to the power of 1 greater than the pre-existing power. Okay, 1 greater than the pre-existing power upon n plus 1. n plus 1. With that, while integration, it's definitely you should indicate an arbitrary constant, okay, arbitrary constant. In all cases, when we deal with integration, in all cases, you should definitely indicate an arbitrary constant, okay, because why we are using that? When we integrate, we don't know what is the exact value of this. When we differentiate, there is a definite procedure to find the differentiation and the derivative, but for integration we have to do that by ourselves by using this formula. No, we don't know this formula is correct or not. For that, to equalize this formula to a proper manner, we have to use an arbitrary constant. Okay, use an arbitrary constant. That's the explanation what we need to integrate some variables. Okay, let's do an example. For an example, when you took x to the power of 5. Okay, x to the power of 5. While the integrate, you have to write, okay, this mark indicate the integration. X to the power of n plus 1. Here already n means the power of pre-existing x particle, that is 5. With that 5 you should add number 1. Okay, number 1 upon, in denominator, n plus 1. With that you should add an arbitrary constant. Okay, then x to the power of 6 upon 3x plus c. That's all for our integration in here. Okay, that's all for our integration in at here. Okay, when we deal with n, okay, I told you when we deal with these kind of example, we can directly, n is greater than 0, we can use this method. X to the power n's integral should be x to the power of n plus 1 upon n plus 1 plus c. Okay, when we deal with x, okay, n is less than 0. Okay, n is less than 0 situations. In that case, what do we need to do? Integration is exactly opposite to our differentiation. So when we deal with n is less than 0, okay, n is less than 0, the formula which we have to use to integrate is same, but the procedure is little different. Okay, when we differentiate 3 upon, okay, 3 upon x to the power of 7. Okay, in this case, what do we need to do? First of all, we can deal with denominators. Okay, we can deal with denominators. If it has any variables, we have to take this denominators variable to our numerator first. Okay, 3 remains same. When we take the denominator x to the power of 7 to our numerator, it will become its negative power, x to the power of negative 7. Okay, that means this is 1 upon x to the power of 7. When we try to find the reciprocal of this, it will become x to the power of negative 7. Okay, the exact same thing I indicated here also. 3 is a constant. Then after 1 upon x to the power of 7 will become x to the power of negative 7. Okay, x to the power of negative 7. Furthermore, the task is easy. You should convert the power as a negative 1 first. Then after, let's bring this 3. Okay, 3 is a constant now. Like differentiation, we can bring our 3 outside. It will become x to the power of negative 7. Okay, negative 7. So 3 is a constant. When you think about this case, okay, x to the power of n, we can consider this negative 7 as a n. So x to the power of negative 7, with that you should add 1. You should add 1 upon negative 7 plus 1. With that you have to add an arbitrary constant. Okay, you have to understand what is happening here. X to the power of negative 7 is our variable which we have to integrate. In here you can see the power is in its negative form. No? With that you should add number 1. That's the formula. By using the formula you should think about it. Okay, x to the power of negative 7, with that you should add number 1. Similarly in denominator also negative 7 plus 1. So it will become 3 into x to the power of negative 6 upon negative 6 plus 3. X to the power of negative 6 upon negative 6 plus 3. Okay, plus 3. Furthermore, just we can do our simplification. Okay, when we simplify, these two can be simplified. Okay, 1 3s are 3, 2 3s are 6. So finally, I'll write your answer here. It will become negative half x to the power of negative 6 plus c plus c. That is our integral of given function. Okay, integral of given function. You have to understand what happened here. Okay, first of all, I'll repeat once more what we did earlier. Okay, in this case, you can see this is our formula. If x to the power of n's integral should be x n to the power plus 1 in denominator n plus 1. Okay, plus an arbitrary constant. When we deal with x to the power of 5, you can see in this example. Okay, in this example, you can see x to the power of 5. That means x to the power of n plus 1. In integral, you have to indicate n plus 1. So 5 plus 1 in denominator also 5 plus 1. X to the power of 6 upon 6 plus 3. That's all for here. But when we deal with negative x powers, okay, negative x powers, that means the x is located in denominators. You have to take that denominator as a numerator first. Okay, that's kind of reciprocal work. Then after you can differentiate that one. Okay, don't bother about it. Okay, you have to think this value as a n. Okay, this value as a n. So it will become x to the power of negative 7 plus 1 upon negative 7 plus 1. Okay, so the x to the power become negative 6. In denominator also we have a negative 6. Furthermore, we can simplify. No, that's how I simplified 3 and 6. So it will become negative half times x to the power negative 6 plus 3. That's all for our integration.